First of all, if we look at the formula for things and see how that's important. So let's look at the example of magnesium hydroxide. First of all, magnesium hydroxide has the chemical formula of MgOH2, and this little S here tells us that at the moment this magnesium hydroxide is in a crystal lattice, it's solid. We could take the magnesium hydroxide and, following the same steps we've just looked at, write this out as an ionic formulae. So again, all we're doing now is we're showing the charges on the ions as well as the ratio. So this is the magnesium ion, Mg2+, and this is the hydroxide ion, OH-. And again, the ratio is 2 hydroxide ions for every 1 magnesium ion, and we need to put the OH- in brackets and show the 2 after it to show we've got 2 hydroxide ions. Again, it's still in the solid state, it's still in its ionic lattice. So this is the chemical formula, this is the ionic formula. Now, again, if you look up in your solubility tables, you see magnesium hydroxide is highly soluble in water. So if we were to drop some magnesium hydroxide into water, it's going to dissociate, it's going to dissolve and break up into individual ions. So we can show this dissociation of this solid sodium magnesium hydroxide, and we can show it dissociating into separate ions. So the Mg2+ ion is going to go into solution. We know it's in solution now because of the AQ sign. And the hydroxide ions are also going to go into solution. However, the way we write this changes slightly, because here the little 2 in the formula tells us that these hydroxide ions are bonded within this solid lattice. And when these dissociate, these 2 hydroxide ions that we've got bonded in the lattice are going to break up into separate hydroxide ions. So we're going to change it by putting the big 2 in front of the OH-. So the OH-, this is the hydroxide ion, and this big 2 here means I've got 2 moles of hydroxide ions. And these are separate now. If we've got big numbers in front of things, it means that these OH- ions are separate. And we know they're in solution again because of this aqueous state symbol here. So look out for this. So when you've got your ionic formulae in the lattice, you'll have these little numbers in subscript numbers here telling us that all of these ions are bonded together in the ionic lattice, okay, in the solid state. And to show that these ions break up into individual ions, we then swap this little subscript 2 to a large 2, and this means that these hydroxide ions are now separate from each other and in solution. If we look at another example of ammonium carbonate, again, the chemical formula for ammonium carbonate you should be able to work out using your valency rules. So the ammonium has a valency of 1, the carbonate has a valency of 2. We swap the numbers over and we'll see we end up with this formula here, NH4 2CO3. Now at the moment, this ammonium carbonate is going to be in the solid lattice. We know that because of this S state symbol. We can also rewrite this because it's an ionic compound made of ions. We can rewrite this as an ionic formula. And again, all we're doing now is we're showing the charge on this ammonium ion, which is 1+, and the charge on the carbonate group ion here, which is 2-. And again, if you look up in your solubility tables, you'll see that ammonium carbonate is very soluble in water. So if we were to drop this into water, these ions are then going to break up into individual ions and dissolve and dissociate into solution. So we're going to take the ammonium ion here, and remember the formula here is telling us we've got 2 ammonium ions for every 1 carbonate ion. And when these dissociate, we're going to take this subscript 2 here, make it a large 2 here, and this means I've got 2 moles of separate ammonium ions. Okay, and these are in solution now, so we use the AQ state symbol. So again, we've changed this subscript 2 into a large 2 in front of the NH4 to show these are now separate ions and they're in solution. We've only got 1 carbonate group ion in our formula there, so we just simply write this out as CO3 2-. That's the 1 carbonate group ion there. And again, we're going to change this to an AQ to show that this is now separate and dissolved in solution.